That log that is in A, show that log x base r to the power 2 is the same as half log x base r. The property that I'm going to use is this different base logarithm. Log x base 8 can be written log x base b over log a base b, and b can be any number that we wish. So in this case, since they want me to express the logarithm in base r, so that is going to be my b. So the left hand side, I'm going to rewrite this as log x to base r over log r squared to base r. Using this property, let me get it and from the formula booklet as well, which is this property. Log x to the power m base 8 can be written as m times log x base a. That's it. I can express the bottom, the denominator, as log x base r over, bring the power down, to log r base r. And we know that log a base is equal 1, so that renders the denominator to be 2 only. So log x base r over 2, which is the same as half log x base r, q e d. So that is part A. It is simple. B, they gave me an equation, log y base 2 plus log x base 4 plus log 2x base 4 is equal 0. He wants y in terms of x to be expressed y is equal p x to the power q. Alright, so we have log y base 2 plus log x base 4 plus log 2x base 4 equals 0. Once again, I'm going to utilize different base theory, log x base a, and to express log x, or I can combine, no, I'm going to do that. So I'm going to express this one in terms of this base. I want to change it to 2, and this one I want to change it to 2. So I'm going to use different base theorem. So that'll be log y base 2 plus log x base 2 over log 4 base 2 plus log 2x base 2 over log 4 base 2 equals 0. Log 4 base 2 is the same as log 2 to the power 2 base 2. Bring the power down, that'll be 2 log 2 base 2, which is equal to 2 times 1, which is 2. So the denominator in both cases will be 2. So it'll be log y base 2 plus log x base 2 over 2 plus log 2x base 2 over 2 is equal 0. If I multiply the entire equation by 2 to get rid of the denominator, so that will render my left hand side to be 2 log y base 2 plus log x base 2 plus log 2x base 2 equals 0. Using the same power property, the reverse of it, which is this one, log x to the power m base a is the same as m into log x base a, or I can take this and put it back if it is in front of it. So that is what I intend to do in here. So picking up the 2 in here, the 2 in here, and this becomes log y squared base 2. So log y to the power of 2 base 2 plus log x base 2 plus log 2x base 2 is equal 0. Then I will utilize this property, the product log x times y. I can expand it as log x base a plus log y base a, or if it is expanded, I can condense the logarithm. So I'm going to condense the left hand side to be one logarithm. That will be log, using that property, y squared times x times 2x base 2 equal 0. And this one can be written as log 2x squared y squared base 2 is equal 0. Using the property of the basic definition of logarithm, log x base a is equal y if and only if a to the power y is equal x. This to this power is equal to the logarithm. Likewise, 2 to the power 0 is equal to the logarithm, which is 2x squared. So I can write this one as 2x squared y squared is equal to 2 to the power 0, and 2 to the power 0 is 1. Therefore, y squared is equal 1 over 2x squared. Square root of this, square root of that, that will be y is equal 1 over square root of 2 times x. And if I can take x up, that will be y is equal 1 over square root of 2 x to the power minus 1. So in this case, he wanted y equal p x to the power q. So in this case, p is equal 1 over radical 2 and q is equal minus 1. Q. Okay, next question. We have two simultaneous equations and we need to solve for x and y. I put these properties that we might be utilizing. So using the quotient rule, I will rewrite the first equation as ln y minus ln x is equal to. So here is my equation 1. Equation 2, I can use the second property and bring the power down. So that will be 2 ln x plus 3 ln y is equal 7. That is equation 2. Now let's arrange the equation with the terms underneath each other, the x and the y, and eliminate. So that will be minus ln x plus ln y is equal to, and 2 ln x plus 3 ln y is equal 7. It is easy to eliminate x, so I'm going to multiply the first one by 2. By 2 I have additive inverse automatically, and this becomes 4. So minus 2 ln x and 2 ln x cancels. Add, that will give me 5 ln y is equal 11, or this can be expressed as ln, using the power property, ln y to the power 5 is equal 11, and I can use the inverse property of e, so I take e to both sides, and we know that e and ln are inverse functions, so that will give me my left hand side, y to the power 5 is equal e to the power 11, the fifth root of both sides, the fifth root, that will give me y is equal e to the power 11 over 5. Substitute that into either equation. I'm going to substitute that into the first equation. Ln y minus ln x is equal to, so ln y minus ln x is equal to, so ln e to the power 11 over 5 minus ln x is equal to, bring the power down using the power rule, that will be 11 over 5 ln e minus ln x is equal to, and we know that ln e is 1, so that will be 11 over 5 minus ln x is equal to, move ln x to the right hand side and move 2 to this side, so we have 11 over 5 minus 2 over 1 is equal ln x. Make a common denominator, that will be 11 minus 10 over 5, that will be 1 over 5 is equal ln x. And now we use the property of taking e to both sides. E and ln are inversely cancelled, so x is equal e to the power 1 over 5. And that is the solution.